ম্যাডাম বলছেন ঠিক আছে, তাহলে তুমি সতীশকে ডাকো, বুঝিয়ে দেবে, ও বানাবে। বললাম যে আমি নিজেরটা কেন দেবো ওকে? ও নিজের আলাদা বানাক, ও বসে থাকবে। না, ওটা তো অ্যাচিপেডাবেই ছিল, অ্যাচিপেডাবেই বানানো। বুঝলেন না?
সবাই শুনতে পাচ্ছেন? গুড আফটারনুন। গুড আফটারনুন এভরিওয়ান।
গুড আফটারনুন স্যার।
সবাই শুনতে পাচ্ছেন? Can everyone listen to me?
ইয়েস স্যার।
সবাই শুনতে পাচ্ছেন? So today in pharmaceutics, we are going to discuss a new part, a new chapter, that is size reduction, or the reduction of the size or the unit operation, which is very much important for your syllabus. So today we are going to discuss the unit operation chapter. Now I'm going to share the screen in which we are going to discuss about the chapter unit operation. So in introduction part, unit operation are those operations wherein no chemical reaction are involved. That means there are no chemical reaction, and unit operation involves a physical change or chemical transformation such as size reduction and size separation, mixing, filtration, and so on. These are the points that are naturally to be discussed. And unit operation is of a primary activity where physical forces are involved. Various types of physical forces are involved in it. কেউ কিছু বলছেন? কেউ কিছু বলছেন? Okay. So now, in the meanwhile, let us start about the first important point, that is size reduction. What is size reduction? Size reduction is a physical dimension of an object. Reduction refers to this method of decreasing in the size. That means the way of reduction of the size and the process in which we can reduce our size is called size reduction. Next, the process of size reduction, it is a method of decreasing the size and usually employed in pharmaceutical industries. They are generally used in the pharmaceutical industries. And size reduction or comminution or grinding, that means to reduce the size of any particle. This is called as grinding or size reduction. Naturally, you all use grinder or grinder machine. All the women, those who are at home, when they cook at home, they use the grinder. So what is the use of grinder? The grinder is naturally used to reduce the size of any spices that we naturally use for cooking. And a unit operation is to reduce the size of bigger particles into smaller particles using some external forces. So the size reduction is naturally done from the bigger particle size to the smaller particle size by using some forces. Those forces are called external forces. Next, we are going to discuss about the objectives of size reduction. What are the objectives of size reduction? The objectives are to increase the surface area of the substance, to increase the surface area of the substance naturally, and in order to increase maximum contact of the solid particles with dissolution medium, resulting in faster absorption of the drug. And in the second case, if we come to know that breakdown of a material into very small particles in order to separate the two constituents and to achieve an intimate mixing. That means the mixing should be very fine. To improve the handling characteristics, that means to improve the characteristics of handling, that means it can be used much more easily. And to reduce the bulk of the material, to reduce the natural bulk of the material, we have to use this. If anyone have any question, you can use your chat box to ask the question. I will surely answer you. To improve the extraction process of the crude drug, that means we can improve the procedure of extraction of any type of crude drug that we naturally do in our pharmaceutical laboratories. To improve the stability of the various dosage forms as emulsion, suspension, etc. And in tablets formulation, size reduction maintains the uniformity of color, order, taste, and functioning. These are the very much important points that we have to keep in mind. To increase the rate of drying is increased very much, and to dispose the solid waste easily. To dispose it very easily, it is also an important point. If we talk about the mechanism of size reduction, we can see it is divided into mainly 4 parts. First one is impact, second one is attrition, third one is compression, and fourth one is cutting. In case of impact, we can see that it occurs when the material is more or less stationary and is hit by an object moving at high speed, or when the moving particle strikes a stationary phase. And in case of attrition, we can see when the moving particle is compressed between the edges of the two tangentially moving hard surfaces against a hard surface, resulting in shear force, which breaks the particles. And in case for compression, breaking of the particle by crushing with the application of pressure and nutcracker. In case of cutting materials, we can see that it can be cut by means of sharp blade. We all know that we can cut any drug particle by using the sharp blade. If we talk about the factors affecting size reduction, we can see that hardness of the first point is hardness of the material. First point and foremost important point is hardness of the material. Hardness of the material is directly proportional to the size reduction, and harder the material, it is more difficult to reduce the size of the material. So it is more hard to reduce the size when the drug particle will be more harder. যদি বেশি শক্ত হয় সেটাকে ভাঙতে আমাদের অসুবিধা বেশি হবে. In case of toughness, if we talk, the drug containing high moisture or fiber are the tough of drugs, and toughness of the material is directly proportional to the size reduction. And the tough of the drug, it is more difficult to reduce the size, and to reduce the size of the soft and tough material is more difficult than to reduce the size of the hard and brittle materials. Example of tough materials includes rubber, green and twig, etc. In case of abrasions, we can see that softening temperatures, stickiness, moisture content, and 50% of the moisture content is seen in the drug. Next, if we talk about the mills, there are various types of mills which are used for size reduction. First one is hammer mill. What is hammer mill? I will show you the picture. What is hammer mill? I am sharing the screen now. You all can see the hammer mill. Now, can everyone see the picture of hammer mill? Okay.
Yes, sir.
So now, this is the hammer mill, this is the construction, and this is the working of the hammer mill. So what is hammer mill? What is its function and working principle? It works on impact. The principle of hammer mill is on impact. And impact occurs when the high-speed rotation hammers hit the more or less stationary material. This impact results the material to break or shatter into smaller pieces. Next, if we talk about the working, how does the hammer mill work? The material is fed into the grinding chamber of the first. Here, this is the material feeding area where we feed the material and the mill through the hopper using a gravity, natural gravitational force. Now next, if we talk about the shaft and rotated shaft at a high speed of 5,000 to 10,000 RPM, inside this there is a rotating shaft which rotates in 5,000 to 10,000 RPM, and the centrifugal force causes the hammer to swing out radially. Next, perforated metal screen that covers the outlet. This is a perforated metal screen that covers the outlet, and the opening of the mill retains coarse material for further grinding, while material of the desired or proper size can be obtained through resulting in finished product. That means after grinding or reduction of the size of the particles, we can obtain a better and more useful size reduced product. Next, if we talk about the advantages about the hammer mill, we can see that, or we can know that rapid in action, and it can grind number of different types of materials, and size and shape of the material can be controlled by varying the speed of rotator, and the type of hammer and mace are used. They are naturally of metallic in body. Due to the swinging of the hammers and changes of jamming reduces an operation of the continuous motion. Chances of contamination are very low as no surface of hammer mill moves against each other. If we talk about the disadvantages, we know about some disadvantages and I am going to mention some. So in case of hammer mill, we can discuss about only 2 points. Their generation of the heat, which can occur due to the high speed of rotator or rotor operation that may degrade the heat sensitivity of material of drug containing the gums, fat or resins. Choking of mill can occur if rate of the feed is not controlled and resulting in decreased efficiency of the mill. In case of application, to produce intermediate grade of powder in pharmaceutical industries for the process of wet or dry granulation to produce compressed tablets. It is used for milling pharmaceutical raw materials, herbal medicines and sugar. It is used in powdering of bark, leaves and roots of medicinal plant except sticky material. It can also be applied in the milling of active pharmaceutical ingredients, that is API, active pharmaceutical ingredients. In short form, it is called as API or excipients. So with this, we come to the end of the hammer mill. Next, we are going to discuss about the ball mill. This is another machine which is used in case of size reduction. What is the principle of ball mill? The ball mill works on the principle of impact and attrition. Both it works on impact as well as attrition. The particle receives impact from the moving ball and attrition occurs due to the sliding motion of the ball over each other. Next, if we talk about the working of the ball mill, we can see that material is first feed into the cylindrical of the ball mill. First, let me show you the picture of ball mill, then I will tell further. Wait, give me 1 second time. I'm going to show you the picture of ball mill. So now you can see the picture of ball mill. This is the structure of the ball mill. Inside that there are metallic ball kept, and the fed or the material that I want to reduce the size, it will be put inside that and it will start rotating. When it will start rotating, then all the metallic ball will hit each other and they will reduce the size of that particular particle. Material which is fed into the cylinder of the mill, the amount of the material should be neither be larger, as it may exert a cushioning effect, nor be very less, which may lead to the loss of efficiency or abrasion. The cylinder is rotated on its axis with rotational frequency of 0.5 per second. The speed is 0.5 per second. The speed of the ball mill should be controlled way. It should be in a controlled way. It should not move at very high speed or very high rate. At low speed, that is the ball which slides or the roll over each other, and very less amount of the material undergo size reduction. In case if we put the ball mill in a very high speed, then centrifugal force occurs and throws the ball towards wall. This will result in no or less size reduction. In case of optimal speed, that is at 2/3 of the speed, ball are carried to the top of the mill and it falls on cascade manners. This results in impact of the material to the ball and attrition of the particle between the balls. So third step, optimal speed is the best for size reduction in case of ball mill. If we talk about the advantages, it is capable of grinding wide variety of materials of different character and hardness. Toxic material can be easily grinded as the material is completely enclosed in a ball mill. Very fine powder can be obtained by use of a clarifier in conjunction with mill. Ball mill can be used for continuous operation, suitable for wet and dry grinding. If we talk about the disadvantages, chances of contamination of product are more due to the wear that occurs due to either moving balls or casing. Soft and sticky material cannot be grinded. It is a noisy machine and consumes much more of energy. If we talk about the applications, ball mill are used to reduce the size or for milling of hard materials such as minerals, glass, advanced ceramic, metal oxide, solar cell and semiconductor materials, nutraceuticals and pharmaceutical materials, and so on. Ball mill can be used equally well for wet or dry grinding. It is used for grinding of ores, used for grinding of drugs and suspension. So with this, we come to the end of the ball mill. Next, we are going to talk about the size separation. If we talk about the size separation, size reduction process leads to the particles of non-uniform size. In order to get uniform size particles, a technique is used to separate the particles of specified size. It is called size separation. It can also be applied for measurement of the particle size to maintain the quality of final product. And the objectives are to formulate a uniform dosage form, to prepare granules of required size, to separate undesirable particles, to have good flowability of powder. Particle having same size are less susceptible to segregation, to measure the particle size and size distribution for better quality of the dosage form. Just give me 1 minute time. Next, we are going to study about the classification of powders according to IP. Generally, every solid used in pharmacy must be handled as powder at some stage. Most of the pharmacopoeia has laid down some standard for the powders used in the pharmaceuticals. The degree of coarseness or fineness of the powder is distinguished and expressed by size of the mesh through which particle passes. If the particle is retained on the mesh, it is called as oversized particle. And if it passes the mesh, it is termed as undersized particle. As per the Indian Pharmacopoeia, powder are graded into 5 grades, which are as under coarse powder, powder of which all the particle pass through a sieve with nominal mesh aperture of 1.70 millimeter. This is a very much important point that you have to note. And not more than 40% through a sieve with nominal mesh aperture of 355 μm micrometer is called as coarse powder. Next, if we talk about the moderately coarse powder, a powder of which all the particles pass through a sieve with nominal mass aperture of 710 micrometer and not more than 40% through a sieve with nominal mass aperture of 250 micrometer is called as moderately coarse powder. Moderately fine powder, if all the particles of a powder pass through a sieve with nominal mass aperture of 355 micrometer and not more than 40% through a sieve with nominal mass aperture of 180 micrometer, as it falls into this group. In case of fine powder, in case all the particle pass through a sieve with a nominal mass aperture of 180 micrometer and not more than 40% through a sieve with nominal mass aperture of 125 micrometer, it is called as fine powder, and so on. In case of very fine powder, if all the particles of the powder pass through a sieve with a nominal mesh aperture of 125 micrometer and not more than 40% through a sieve with nominal mesh aperture of 45 micrometer, it is said to be very fine powder. In case of microfine powder, a powder of which not less than 90% by weight of the particles pass through a sieve with a nominal mesh aperture of 45 micrometer. In case of superfine powder, a powder of which not less than 90% by number of the particles are less than 10 micrometer in size. As per Indian Pharmacopoeia, the powders are classified on the basis of their size and mentioned. In case of coarse powder, 10 to 1.70 micrometer, 44 to 335 micrometer. So with this, we come to the end of the discussion of today's class, that is the size separation and so on. Now give the attendance. Okay, the attendance is taken automatically. You all can leave the class now. Thank you very much.